Yes friends, welcome once again to the class, and let's start our discussion that we are going to learn about this particular problem number 2. Up to here we had already learned in the previous class, right? This particular problem, parities of p electron and alpha particle are not the same, that we had already learned that. Now we are going to learn about this particular problem number 2. Just a second, just let me put it to the upward side. Okay. Obtain an expression for binding energy per nucleon for the nucleus of an atom. Okay, we have to obtain the expression for binding energy per nucleon. Okay, so expression for binding energy per nucleon for the nucleus of an atom with atomic mass mza. Okay, atomic mass is equal to, that is, the atomic mass is m. Just don't confuse between atomic mass number and atomic mass. Okay, do not get confused between atomic mass number and atomic mass. Okay, a is atomic mass number, z is atomic number, and m is the atomic mass. Okay, so atomic mass is the actual isotopic mass. Atomic mass is actual isotopic mass, and atomic mass number is total number of nucleons. Okay, let me repeat this. Atomic mass number is total number of nucleons in the nucleus. Okay, atomic mass number is total number of nucleons, and atomic mass is actual isotopic mass. So do not get confused between them. So we have to obtain the binding energy per nucleon for nucleus of an atom with atomic mass equal to m, where z is its atomic number and a is the atomic mass number and m is the atomic mass, in terms of its packing fraction f. Okay, we have to find this particular value of m in terms of packing fraction f. Okay, and the packing fraction of proton and neutron are also given to us. Okay, the packing fraction of this particular entity is equal to f. Okay, and packing fraction of proton, what is the packing fraction of proton given to us? It is given as fp. And packing fraction of neutron, what is it given out? It is given as fn. Okay, so packing fraction of proton is fp, neutron is fn, and atomic mass is m, atomic mass number of the nucleus is a, and atomic number is z. Atomic number is z, atomic mass number is a, and atomic mass is m. Okay, such is the situation which we have with us. So we have to basically find out the value of this particular entity, that is mza, in terms of f, fp and fn, where f is the packing fraction of this nucleus, fp is the packing fraction of proton, and fn is the packing fraction of neutron. Okay, so let us see how we can find this particular value in terms of not this particular value, we have to find out the binding energy per nucleon in terms of this and this. Okay, I am really sorry for the confusion. Binding energy per nucleon we have to find out in terms of mza, f, fp and fn. Okay, so in terms of 4 entities we have to find out binding energy per nucleon. Now binding energy per nucleon of the nucleus mza is given as, you have already learned this in the previous lectures. This particular formula you have already learned in the previous lectures, that binding energy per nucleon of the nucleus mza is given as EB bar. Okay, EB bar equal to EB divided by A. A is what? Atomic mass number A. Okay, so A is the atomic mass number, and atomic mass number is the total number of nucleons. So binding energy per nucleon will be binding energy divided by total number of nucleons. Binding energy per nucleon will be equal to binding energy divided by total number of nucleons. And binding energy, the formula of binding energy we already know. Okay, formula of binding energy we have already learned in the previous lectures, right? So we have just substituted that formula. Z is what? Z is your atomic number. A is what? Atomic mass number. mza is what? Isotopic mass. Okay, mh is what? Mass of proton. Mn is what? Mass of neutron. Okay, so we have got this. Now if we look at this particular expression, then we will have to eliminate mh and mn over here. See, this particular quantity C square is a constant. Okay, so we need not eliminate this. Okay, we need not eliminate C because C is a constant. We need not eliminate A because A is given to us in the question. We need not eliminate this because it is given to us in the question. We need not eliminate this also because it is also given to us in the question. This also we need not eliminate. What do we need to eliminate then? We need to eliminate mH, that is mass of proton, and we need to eliminate mass of neutron from this particular expression and substitute these values in terms of packing fraction Fp, Fn and F. Okay, so we have to do this particular exercise now. So let us see. This formula is already familiar to you. You have already learned this in the previous lectures of this particular playlist itself. If you haven't watched the previous lectures of this playlist, you can go to the link in the description and click on that link and watch from the very first lecture if you are new to this channel. Okay, this is the nuclear and particle physics series which is going on right now. Okay, so ZMH plus A minus ZMN minus MZA C square divided by A. This is the binding energy per nucleon of this particular nucleus. Okay, now let us consider this to be equation number 1. Okay, so packing fraction for proton, that is nucleus of hydrogen, packing fraction of proton or nucleus of hydrogen, what do we have? Fp will be equal to mass of isotopic mass of this particular entity minus A, that is the atomic mass number of proton, which is equal to 1 divided by A. So 1H1 minus 1 divided by 1. So isotopic mass of 1H1, that is mass of proton. Okay, that is equal to 1 plus Fp. Similarly for neutron, what do you have? Similarly for a neutron, you have such a situation that you will have mass of neutron minus A divided by A. Okay, now atomic mass number of neutron is equal to 1. So Mn minus 1 divided by 1. So your Mn, that is mass of neutron, will be equal to what? Fn plus 1. Okay, Fn plus 1. So that's how we have got this particular expression, that is mass of neutron equal to 1 plus Fn. Okay, that is 1 plus packing fraction of neutron. Okay, so we have got this. So whether you write like this or write like this, that is the same. Okay, whether you write like this or write like this, that is the same. And nucleus of hydrogen is the same as that of proton. Okay, what is nucleus of hydrogen atom? Nucleus of hydrogen atom is same as proton. Okay, because the nucleus of hydrogen atom consists of a single proton and no neutron. So that's why nucleus of hydrogen atom consists of a single proton. Okay, so that's how we are writing, instead of P, instead of writing P over here, P as the suffix over here, or P over here, instead of writing that, we are writing a hydrogen symbol because the nucleus of hydrogen atom is same as that of proton. Okay, same as that of proton. That's why. Okay, for the given nucleus also we can apply the same formula of packing fraction, that is MZA, that is the mass of the isotopic mass of the nucleus, minus A divided by A, where A is the atomic mass number of the nucleus. This is the isotopic mass of the nucleus and this is the packing fraction of the nucleus. Now MZA, what do we need to eliminate? We need to eliminate MH, Mn, okay, and MZA. Okay, we have to eliminate from here. From here we have to eliminate MZA, Mn and Mh, and we have to substitute all these terms in terms of packing fraction. So MZA, successfully we have got A into 1 plus F. Okay, so substituting these values in equation 1, what do you get? Instead of 1H1 and MH, we substitute 1 plus Fp. So substitute 1 plus Fp over here. Okay, then what do we have next? Mn equal to 1 plus Fn. So substitute in the place of Mn 1 plus Fn over here. Okay, and instead of MZA we have to substitute instead of mza, we have to substitute from here in terms of packing fraction a into 1 plus f. Okay, so we substituted a into 1 plus f. So what did you get then? You got this particular expression. This expression became like this. Okay, like this it became. Now, so the problem is over, but over here one thing is missing. What is missing over here? What is missing? C square divided by a, the thing which has been written over here, c square divided by a, the term is missing over here. Okay, so just put it over here. C square divided by a will also come over here in the multiplication. Okay, so make a correction over here while making the notes, that this particular expression will also come. Okay, this particular expression c square divided by a, which was present in this particular equation, c square divided by a, which was present, that will remain as it is. Okay, so c square divided by a will also come in multiplication. No symbol means multiplication, right? So this expression will also come in multiplication. So this is the expression for binding energy per nucleon. This is the expression for what? Binding energy per nucleon in terms of what? Packing fraction of the nucleus, packing fraction of, in terms of packing fraction of nucleus, packing fraction of neutron, and packing fraction of proton. Rest other things are already given to us, like a and z. No need to eliminate them. Okay, c square divided by a will additionally come over here. That's it. Okay, so that's how this problem was to be solved. Okay, now the third problem we will do in the next class. Okay, so thank you very much.